Hey everybody, I'm Chili. Welcome back to Beginner C++ Tutorial 17. Today we're talking about measuring time with modern C++ features. Now the problem with our games is our children's learning? No. The problem is that entities move at a fixed rate every frame, and the game's frame rate is locked to the refresh rate of the monitor. So different people with different monitors will experience different speeds of gameplay. And that's going to make the game, more difficult for some people, could even make it unplayable. Also, and this hasn't been a problem so far, but what happens if we have so much going on screen that we can't draw at, say, 60 frames per second? So the game speed is going to slow down. So yeah, we're going to measure the time elapsed every frame and then step our game by an amount that is proportional to the amount of time that has elapsed, basically. So we need to measure time, and we're going to be using a new feature of C++ 11, the Chrono library, which is a sub-library of the standard library. So to start off with, we're going to do a bit of testing and fooling around, and you can do this in any solution, but I'm going to clone a fresh framework solution here from the repo. So copy that, paste it in here, and clone that shit. Then you got to make sure you're connected to the right repo here. So you connect to Chrono Rolled, open up that solution. And let's just jump right into game.cpp here. So we got our empty game.cpp. We're going to add in, where's my enter key? There it is. All right. Include, that's not how you spell that. Chrono dot, no, not dot or anything, just Chrono. All right, include Chrono. Why are you fucking unrecognized pre-processing directive? Are you fucking kidding me?
Are you kidding me? That's right. Who do you think you are? I am.
All right, you'll get over it. All right, so Chrono, what do we got? Well, let's take a look at the page for the thing. So here is CPP reference. I use it quite a lot. It's good stuff. I don't know if it's good or not, but I use it. All right, so date and time utilities, Chrono library. Now you got 3 clocks that are defined. And what you can do is you can use these clock objects. So 3 kinds of clocks. System clock is where you look at if you want to figure out what time it is, in the PM. But if you want to measure performance, I recommend using the steady clock. But it doesn't really matter. In Visual Studio, steady clock and high resolution clock are implemented the same. So it only depends if you're working on other platforms. So we're going to use steady clock. So let's do some shit here. So std. Now there's a sub-library Chrono, so we type Chrono. And then we can look at some shit. So we want steady clock. Steady clock. So we get the steady clock, and now there's a function called now, and that function will get us the time, the current time point. So when you're working with Chrono, you get time points, and then you can get durations from that. Well, you'll see what I mean when we get there. So we need to create a time point object that will store the now time point. So we're going to go std Chrono, and there's a guy in the comments, and he is like, I hate these double colons, and I'm like, how you like me now, huh? Kappa face. Let's see here, steady clock and time point. So you can get a time point for the steady clock like this, and we're going to call this time point start. So start is equal to now. And then what we're going to do is we're going to execute some kind of operation. All right, we're going to do an operation like this to burn some time. Quick quiz. What is this going to do? The answer is it's going to fill the screen with green, hopefully, unless I fucked something up. Anyways, so we get the start point, the time point of the start. Now we're going to get another time point, end. So we're going to call steady clock now after we've completed this operation. And that'll get us a start point and an end point. Now, start points and end points, they don't do anything for us. What we want to do is we want to measure how much time has passed between these two calls to now. So what we need is a duration. So std chrono duration. And we can have durations of different types. So we can have a floating point durations or integer durations. We're going to use float. So we're going to measure our duration in seconds using floats. And it's going to be, we'll just call this the runtime. And we can just calculate the runtime by doing end minus start. So subtracting one time point from another returns a duration, and then you can store that duration in a std chrono duration. And then you're not done. Now we want to get that into a floating point number for the number of seconds that have passed. So we can go float duration seconds is equal to runtime dot count. So when you do the dot count, it's going to return a type equal to this type here that you use to create the duration. So this is a float duration, so it's going to return floats when you call the count function. All right, let's set a breakpoint here and let's run this through the debugger. Now this function is going to take this operation here is going to take a hell of a long time because we're in debug mode, but doesn't matter. It'll be a good test. So we'll run this guy. And we run to the breakpoint, and let us step over this. So right now, duration second is equal to negative lots. So it's some dumb number, big dumb number. Let's step over that. And now duration has gotten a value. This is the number of seconds it took to run this nested loop. You can see here it is 0.039 seconds. This is how we measure time. We get time points, we subtract one time point from another to get a duration, and then we call count to get a float out of our duration. Doesn't have to be a float, could be an int, but we like floats. Now, one thing you might have noticed is that this is a fuck of a lot of typing here. std chrono steady clock, std chrono steady clock. I'm gonna give you so many STDs, girl, you don't even know. Anyways, so what we can do here is if we're using this symbol or this identifier a shit ton, what we can do is we can promote it into the global namespace. So we can go using std chrono steady clock. And what this will say is now whenever I say steady clock, I mean std chrono steady clock. So if I delete this now, the compiler will not have a hissy fit. It will be fine with it. Now I can just use steady clock the way it is. Notice that I can't delete std chrono from the beginning of duration because we're not using std chrono duration. We're using std chrono steady clock. So you have to keep the scope specifiers for duration here. Now you might be wondering, what's all this, double colon bullshit anyways? Why do we have to type std double colon sometimes? And why is it we have to type std double colon chrono double colon? So namespaces are a way of organizing the identifiers in your program. So for example, the random number generator, MT19937 or whatever it is, the min-max functions, the uniform int distribution. These are all they're declared inside the std namespace. And also declared inside the std namespace is the chrono namespace. And inside of chrono, you've got steady clock and duration. You've got namespaces inside of namespaces. Yo dog, I heard you, like whatever, it doesn't matter. All right, so now why would you want to do this? Why is this a good thing? Well, let's say you've got some code and your existing code uses a variable named min all over the place. It's a very common word, so you'd likely have it somewhere. Then you tried to include the standard library. You started to use the standard library, but standard library already has something called min in it. So now you've got a redefinition of a symbol here. These guys are going to fight and they're going to fuck your code up. But That's not going to happen because standard library plays nice. It puts all its symbols inside of the std namespace. So now it doesn't pollute the global namespace. So this is the global. Global. It doesn't actually have the name global, but this is the global namespace. If you don't put an std or anything in front of a symbol, it's going to default to this global namespace. And because the standard library puts all its symbols inside of std, you don't get collision. And the same thing for Chrono. It's putting its symbols inside of the Chrono namespace so it doesn't collide with anything else inside of std. So that's the idea of namespaces. So when you do when you say, using std Chrono steady clock, you're taking this and you're pulling it out into the global scope. And every time you do this, you are polluting the global scope a little more. So you've got to be careful about where you do it and how you do it and how much you do it. So rule number 1 is you want to minimize the damage of using. So if I do a using inside of a function, it only affects inside the function. For example, I can't go steady clock now in a separate function. It won't work because it hasn't been promoted to the global namespace. So using inside of a function is better than using outside, like let's say in the global space. If I go up here in the global space and I go using std Chrono steady clock, then this will be okay. And this will also be okay. So now every one of these functions has been polluted with this steady clock using. But that's not too bad as long as you're not worried about, collision with the name steady clock. But here's what you should never ever do. You could also take this using and put it in the header file. And if you do it this way, now it's available for everything in the game class declaration. And because game is included in here, it's also available in here. But it's also going to promote steady clock to the global namespace in any file that includes game.h. And you don't know who could include it, so you are polluting the namespace excessively if you do a using inside of a header file. Never do a using inside a header file. Never go full retard. Now, there's another way to use the using statement. So this is using a particular symbol, but you can also using a namespace. So using namespace std. And if you do using namespace std, now you don't have to type std before your symbols. What happens is using namespace std, that's going to promote the entire std namespace into the global namespace scope. So everything in here now is going to be into the global scope. And this is commonly done, but again, never ever do it in a header file. Only do it in a CPP file, or even better, inside of the body of a function. So I'm not going to do using namespace std. I don't do it very often, but sometimes I might if I want to get out of a lot of typing for some reason. Now, we've gotten out of a lot of typing by using std Chrono steady clock. But here we still got to type, steady clock and then time point to get a time point for the steady clock. Let me show you a little trick. When you declare a variable in C++, you can declare its type as auto. And what that's going to do is that's going to tell the compiler, I want you to figure out what this variable's type should be. So if you go auto start is equal to steady clock now, well, steady clock now returns a time point for the steady clock. So it's going to make start to be a time point for the steady clock. And you don't have to type that bullshit out. It's just going to be automatically deduced. Now you need to note that the compiler needs a way of deducing the type. So if you go like auto butt plugs and you don't do an equals something, it's not going to know what butt plug should be. Cannot deduce auto type initializer required. So you can't just auto without giving it a way of detecting what it should be. And in some cases it's ambiguous, so you have to specify, but you can use auto. Now, my personal guidelines for using auto is I don't generally use auto if I could use like int or float, because int and float, it's easier to read than auto, right? It says it right there. Whereas if you type auto, then you got to look at this and what does this return? And oh, it returns an int. And so I guess this is now an int. So it's better self-documenting if you type the type out. But if the type name gets to be super long, and it can get to be fucking long indeed, then I get to type auto, because if it's so goddamn long that it's obscuring the code, it's better just to type auto. So your mileage may vary. Some people auto everything. Some people never auto. I love to get blotto. All right, now let's turn our attention again to the Poo game. So you might already have the Poo game cloned. But if you don't, you can clone it. If you do have it, you can just open it up on the local folder like this. And first things first, you might need to synchronize it. So look at history here. So in my history here, I've only got the tutorial 16 start. I don't have anything else yet because I haven't synchronized it. So I can go home, I can go sync, and I can go sync. And this will synchronize. It'll pull all of the new stuff that has changed since the last time I cloned or synchronized. Then I can refresh the history. And now you see I've got a whole bunch more up on here. Now you should see a green tag here that shows you the start point, tutorial 17 start. And you might have other things above that, but doesn't matter. You look for this one, and then you right click and you go new branch. And we're gonna call this one tutorial 17 dev. It doesn't matter what you call it, create the branch. So this will create a local branch and it'll switch to it. And this is where we're gonna be doing our work in. All right, so what we wanna do is we wanna measure the amount of time taken between the frames of our game. So what we're gonna do is we're gonna go project, add new item, and that's bad. Project, no, not project, here. Project, add new item. There we go. We want a header file. And we're gonna call this one the frame timer. And we're going to create a class called the frame timer. Now we're going to include Chrono because we need it. Now for the public interface, we're going to have one function called mark.
Yeah. Can you feel it, baby?
And all that mark is going to do is it's going to take the current time and return a float that represents how much time has passed since the previous mark. So float mark. That's it. Now we need to be able to remember the time point of the previous mark. So we're going to go std chrono steady clock time point, and we're going to just go last. Let's also create a default constructor for the frame timer. So frame timer like that. All right. So what are these guys going to do? Well, the first thing frame timer is going to do when we construct it, and we're going to create definition. And so what this guy is going to do is just going to set the time point. So last is equal to, and so since we're in the CPP file now, let's do a using in here. So we'll do using namespace std chrono. So we'll promote std chrono to the global namespace inside of this CPP file only. Then what we're going to do is we're going to go last is equal to steady clock now. So this is going to, when we create the frame timer, just initialize last to the current time position of the clock, just so it's at some useful value. Now, whenever we call, let's close that. Whenever we call mark, what we want to do, there we go. What we want to do is create a temporary time point, and we'll call this one old, and we'll set it equal to last. Then we're going to set last equal to steady clock now. Steady clock now. Then let's create a duration. So constant. Actually, we can make auto old also constant because it doesn't get changed. So constant duration, float, And frame time is equal to last, because that's the most recent one, so it has the largest value. Last minus old. And then we can just return frametime.count. And this guy is going to get us the time taken for the previous frame, and also update the last or the marked time point. So now we go to game.cpp. We can include the frame timer, and we'll add a frame timer to our user variables. Just call it ft, and then inside of update model here, we can use frame timer to get the delta time for each frame. So we'll go constant float dt is equal to frame timer.mark. And let's just go in here and let's see what happens when we call these functions here. So the first time we call mark, it returns 43 milliseconds. And the next time, 16 seconds, because I was pausing here. I was actually just sitting around in the debugger. So it's going to return how much time has passed since the last time I pressed continue. So 14, 1 second, 0.7 seconds. Interesting, but yeah. So it's obviously when you're running the debugger, the pauses of you just sitting around doing nothing are going to be much larger than the pause of the processing. Anyways, so now comes the interesting part. Well, I mean, this was interesting too, but now comes another interesting part. What we got to do is we've got to take this delta time and use it to determine how much our shit is going to move every frame. So right now, take a look at our poo class. We define the velocity, Vx and Vy, and this is basically, the number here is the number of pixels moved per frame. But now we're not going to be moving per frame, we're going to be moving per second. And the number of seconds is going to be different. So before, we were just moving, that many pixels per frame. So all we had to do was add that amount to X every frame. But now we're moving per second, so we've got to multiply the number of pixels per second times the number of seconds passed, and then add that to X. So what we're going to do is, first off, so the poo update, it's going to need to take the delta time, not the flat delta time, float delta time, because it needs to know how much time has passed so it can do its calculations. And then we're going to go into poo.cpp, and we're going to go float delta time. Before I do this, let me just do something. So I'm going to undo those things. I'm going to go poo.h undo, and that will undo everything I've done there and revert it to whatever it was in the git. Where's poo.cpp? There it is. So I'm going to undo this. All right. So now we have frame timer added, game. All right. So before I add a new feature, I have built and I have tested my frame timer. So I should go to changes and I should commit these changes. So game.cpp, frame timer, yes, these are all good things to change. So added frame timer and frame timer mark call. There we go. So we'll commit that. Now we can start adding the new feature of actually incorporating that delta time into our update. So poo, again, float dt, toggle header code file, float dt. All right, so now we've got the delta time in here. Now we got to use it. So very simple. We multiply our velocity times our delta time. And that's about it. That's actually all we've got to do in there. Now you got to do the same for the dude. So we go to dude. The dude has an update and takes a keyboard. Let's also make it take a float delta time and toggle toggle header code file. Let's see if we can find the update here. Nah, I don't want the draw. Thank you. Let me minimize that damage. Float DT. All right. So now we've got to take the DT into account here. So we do speed times DT. And we do that for all the things. So here, here, and here. And that's about it. That's all we need to do there. Now, because the update calls, the signature has changed, that's going to break the interface. So we've got to go to game.cpp. Where is it? There it is. And we'll look for the red. There it is. Where is it? Why is this red? What is love, baby, don't hurt me? Hate these fucking put pixel calls. Okay, here we go. Now we can actually see where our errors are, and they are here. Update needs a delta time, and update needs a delta time. Now this should build and wait for the poo to compile all the goddamn put pixel bullshit. And if we run it and we hit enter, there we go. And you may notice that everything is moving excruciatingly slow. It is moving, but is moving incredibly slow. And the reason for that is because we have not adjusted our velocities. So our velocities are such that they're calibrated for pixels per frame. But now we're moving in seconds. So 2.5 pixels per second is obviously pretty goddamn slow. So we've got to recalibrate this. So let's make the maximum. Well, we'll just multiply by 60 to basically give us the same values that we had before. Only this time independent of frame. And then if we go into dude, where's the dude? There we go. If we go into dude, we can change his speed, multiplied by 60 to give the same effect that we had before. Now if we run this bullshit, now we see that shit is moving at about the same clip as it was before, and I died. And now if we've tested our shit and we're, satisfied that it's all good, we can commit this to the repo, and we'll just say here, delta time incorporated into entity updates, timestep no longer frame rate dependent. That seems decent to me. And here's our history of commits now. Added the frame timer and incorporated delta time into entity updates. And there you have it. There's Chrono, there's physics time step, and there is namespace management. Now for the homework, quite simple and straightforward this time, no big puzzle. What I want you to do is to apply this same technique to the snake game. So make the speed of the snake game now no longer dependent on frame rate. Shouldn't be that difficult. And thanks for watching. I hope you liked the video. If you did, please click the like button. It helps a lot. And I will see you soon with some more C++.